All right, so let's remind ourselves of the overall strategy for doing feature-based alignment to find transforms. We know how to compute features. That involves both detection, remember all that Harris-Laplace stuff, for finding feature points, and for generating descriptors. We talked about SIFT, where we generate descriptions around the little local neighborhoods of the points. Second, we know how to find some plausible, or what we're soon going to call putative matches. We talked about doing the variation on KD trees, the best bin, hashing methods, basically ways of saying, well, which features are likely to match which other features. I might make some mistakes, but at least they get me some reasonable matches. Then we would have to compute a transform that aligns one image to the next. We talked about doing homographies or affine transforms, and then finally you would apply that transform. Great. All right, so the algorithm follows this pretty carefully, but you'll see in a minute we're going to get to a point where there's a step that we don't know actually how to do. So the first is extract the features. Fine, we do that. Second is compute these putative matches. That's the term that's used. This is what I was talking about doing this KD tree or the best bin. And what you see drawn here, all those red arrows, those are going from some feature in the left to the best feature matching it on the right. Now, if this was nice, if everything was right, you'd see this nice smooth transition. But of course, what you see here is a lot of stuff. In fact, you can see, some of these things tend to be all lined up the same direction, but here's one, right? It goes from here to there. That is clearly, I think the technical word is wrong. So what we'd like to do is somehow figure out a solution to this that makes it clear that we're going to ignore that one and pay attention to another. So after we find the putative matches, then we have the loop until happy routine. Okay, so loop until happy says, hypothesize some transform T from some of the matches. Actually, this is what's going to be interesting, the sum of the matches, okay? And then we're going to verify the transform. We'll talk about what that means in a minute. And we keep doing this until we think we found a solution that's really good. That's what it means to loop until happy, at least today. And then you apply the transform.